All right, picking up with example 3, conditional probability. At a restaurant, 25% of customers order chili. If 4% of customers order chili and a baked potato, find the probability that someone who orders chili also orders a baked potato. My recommendation for these types of problems with conditional probability is to write out what you are given, like the information that you are given first. Okay, so define your events. C is the probability that somebody orders chili. We'll say B is the probability that somebody orders a baked potato. And in the problem, we're given this 25% number. What does that represent? It represents the percentage of customers who order chili. So the probability of C is, we're going to write this as a decimal, 0.25. Okay. And then this 4%, what does that represent? It represents the customers who order chili and a baked potato. So that's our and probability. Probability of C and B. Probability of C and B. So writing that as decimal, we get 0.04. And it's asking us to find the probability that someone who orders chili also orders a baked potato. So it's asking for conditional probability. We have a choice of if we want to find probability of B given C or the probability of C given B. But with the information we have, we're only going to be able to find one of them, okay? So the question of how do we know if we want to find B given C or C given B, we need to write out our formula, okay? So the probability of both events happening equals the probability of one event happening times the probability of one event happening given that the other happened, okay? And I left those blank on purpose. Okay, I left the events blank on purpose. Whatever goes here needs to match the letter that goes here. Okay, so the letter that goes here needs to be C because we don't know the probability of B. We don't know the probability that someone orders a baked potato. Okay, so C needs to go there, C needs to go there. So we are going to put, this doesn't matter, probability of C and B is the same as B and C. But we need to find the probability of B given C. It might seem small, like it's just a notation problem, but it's going to matter eventually, okay? Probability of C and B is 0.04. Now we're just plugging in the numbers that we have, okay? Probability of C is 0.025 times the probability of B given C. To solve this one-step equation, we just divide both sides by 0.25. Sorry, I don't know why I put a 0 there. Divide both sides by 0.25. When we do that, we will get 0.16, which is 16%. But typically with probability, we can leave it as, we should leave it as a decimal less than 1. Okay. Final example has to do with a two-way frequency table. It is sometimes called a contingency table. The best way for me to explain these to you is through an example. So here we go. A drug company conducted an experiment to determine the effectiveness of a certain new drug. Test subjects were randomly assigned to one of two groups, a treatment group who received the drug or a control group who got a placebo. So a frequency table in general is a table that tells us the frequency that things happen, okay? So across the side here, down the side, we have treatment, whether they got treatment or whether they got a placebo, whether they were in the control group. And then over here we have, did their condition improve or did their condition not improve? Okay, and then when you add, with two-way frequency table, when you add the rows and when you add the columns, you'll get totals, okay? And then eventually we will use those totals to help us calculate probabilities, okay? So This is asking us to find the probability that a test subject's condition improved, given that he or she was in the treatment group. First thing I like to do with the frequency table is kind of add an extra row and column at the bottom and at the very right, because this way I can get my totals and have them written out. Because no matter what with the frequency table, you're going to need these totals, so you might as well write them out at the very beginning. Okay, so if I'm going to add this first row, 1600 plus 400 is going to give me 2000. 1200 plus 800 is also going to give me 2000. 1600 plus 1200 is going to give me 2800. And 400 plus 800 is going to give me 1200. Okay? And then the number in this very bottom box should equal the number of total participants in the trial, and it should equal the column plus the very bottom row, right? So 2000 plus 2000 is 4000. 2800 plus 1200 is also 4000. Okay, so I'm going to write total, and that's a really nice way to get your information in one spot. Okay, so the probability that a test subject's condition improved, given that he or she was in the treatment group. Notice that this 2000 up here represents all people who were in the treatment group. This 1600 represents people who were in the treatment group and their condition improved. This 400 represents people who were in the treatment group and their condition did not improve. 1200 represents the control group whose condition improved. And the 800 represents people who were in the control group and did not have an improvement in their condition. Okay? 1200 represents the total number of people whose condition did not improve, regardless of whether they were in the treatment or the control group. And 2800 represents the number of people whose conditions improved, regardless of whether they were in the treatment or control group. So, when we're thinking about this problem, what's it asking us for? It's asking us to find the probability of something given something, right? The probability that the condition improved given that he or she was in the treatment group. So given that he or she was in the treatment group, that's going to go over here after the little bar, which is our T. Okay, given that they were in the treatment group, that's a T. The probability that the condition improved is right here. That's our Y. Okay, that's our Y. So we need to solve, that's what it's asking us for, so we need to fill in the rest of our information accordingly. So since my given is T, I need that to match this probability. And then I need this to be both. Probability of yes and treatment, okay? So the probability of yes and treatment is right here, 1600, right? This is our and. 1600 out of the total number of people in the trial, which is 4000. The probability that they were in the treatment group, it doesn't care whether their condition improved or not. It just wants to know the probability they were in the treatment group, which is 2000 over 4000. And then those pieces of information will help us solve for our unknown. Okay, so take these two fractions, turn them into decimals, and then divide both sides by 2000 over 4000, and that'll give you your solution. Okay, take a second, pause the video, and work through that. Okay, when you get those as decimals, it's 0.4 equals 0.5 times the conditional probability, and then we divide both sides by 0.5 to get 0.8. So the probability that somebody's condition improved, given that they were in the treatment group, is 0.8 or 80%. So that means that overall this drug is pretty effective. Okay? That's all I got.